So clustering is another unsupervised learning technique. And when I say unsupervised learning technique, there is no y variable. We are trying to understand the pattern or extract pattern, right, from the input variables without looking into y variable. In dimensional regression, we try to extract covariance from the data. It doesn't matter whether covariance is important or not. The PCA algorithm will try to extract covariance from the data. There may be other dimensional reduction technique which will actually look into different kinds of things. But in deep learning, it is always based on y variable we try to reduce the dimensionality. So we understood PCA and the math behind it. Today we are going to look into another unsupervised learning technique, which is called as clustering. Clustering is nothing but grouping records. Okay, so if you have 100,000 documents, you may have to group them, right? There are no labels in there, so the process is like this. In a healthcare company, right? A scenario I am actually trying to take. In a healthcare company, you have given 10,000 documents, and you actually need to build a model that tries to predict when a new document comes in, right? That tries to predict which category it belongs to. Okay, this is the scenario. 10,000 documents are given to you, and when a new document comes in, you need to predict which category it belongs to. On these 10,000 documents, you don't have any labels. Do you know what is label? When I say there are no labels assigned to these 10,000 documents, what does it mean?
There is no y.
There is no y, right? Give me 1 second. I'll draw and explain the scenario and then design a solution. Okay. In that solution, where clustering fits, I'll try to explain. This is one way of using clustering, but there is another way also to use clustering as a support for a supervised learning algorithm. Okay. Both I'll try to explain. Give me 1 second. So where exactly the clustering can be used. One of the scenarios where you can use clustering, I am trying to explain. So there are documents. Right? There are 10,000 of them. Okay, there are 10,000 of these documents are there, and these are given to you, right? The data set is like this. When the documents are given, right, what we will do if we have to build a model and try to predict, right? A new document comes in. When a new document comes in, you should predict which class it belongs to. Okay, so as soon as you get the data, what you try to do, you try to extract text from the data and put it into, right, the text in the doc, right, or doc text or text, right? You try to extract the text and put it here, and there is no y variable, right? Even in this, right, you don't have any y variable. So now what you can do is you take each document, right? Take this document, read through it, find out the category. Take this document, maybe this document belongs to COVID vaccine, right? This document belongs to maybe polio vaccine. This document belongs to maybe another maybe drug, maybe paracetamol. This document belongs to glycomet, right? This like that each document, right? Maybe there are maybe 10 categories, right? So read through each document and try to flag it. First document maybe 1, second document 2, third document 1, fourth document 3, For fifth document, maybe 1, like that. Right? There are 10,000 documents. Can we do this? Manual labeling. We call it as labeling, manual labeling. Can we do that? Is it possible?
Manually it is difficult.
It is difficult. It is possible, but it is difficult. If you have, subject matter experts, maybe 100 people, you can give each one 100 documents, and they'll read through and try to label it. It may take a month, right? Maybe each document, if it is 10-20 pages document, right? Every day, maybe 5-6 documents each person can read, and then maybe in a month they'll be able to finish the labeling task. That is one way. Okay, this is one way. Okay, the second way is you take these documents and try to group them automatically, right, to 10 groups, right? 10 clusters, I can say. Take these documents and group them into 10 clusters. Okay, so the second approach is take the documents. When I say take the documents, take the text from it, right? And then put them into this thing, and then convert this into numbers. We'll see how to convert it into numbers. Natural language processing's main objective is to convert your text into numbers, right? NLP, right? It becomes numbers, right? Some feature x1, x2, and so on. This text will be converted to xn number of features, and then each cell will get numbers there, right? And then you apply a clustering algorithm, maybe k-means clustering algorithm, which actually divides each of the text, each of this document, right? First row is document 1, second row document 2, right? All these documents into different categories, right? Then it becomes like this. Then you will get y value, x1, x2, and so on, xn and y, right? For each document there will be one cluster, one group, right? Maybe 2, and maybe 4, maybe 5, right? Maybe 1, 3, like that. Okay, so this is an automated way to grouping the documents when the number of documents are too many. Okay, this is one use of clustering, but the drawback with clustering is it's an unsupervised approach. Okay, and there is no guarantee of these labels. When I say there is no guarantee of these labels, we are not sure whether the labels are correct or not. When I say labels are correct or not, I said that initially 10 groups are there, right? 10 groups, right? Each group is like, this group is COVID, this group is paracetamol, right? This group is glycomet, right? Like that, there are 10 groups. When we did this clustering, right, it doesn't know which number actually belongs to which group. It doesn't know. Do you agree? When we did this clustering, right, it assigned some numbers here, right? Some numbers it assigned to each document. It assigned one number to each document. It assigned one number, but it doesn't know which number is actually COVID, which number is paracetamol, which number is glycomet. It doesn't know. Do you agree with that statement?
May not be, sir, because when we assign some number, with some logic only we assign it, right? So then
so to find out that relation, what we should do? Which number belongs to which category? What we should do?
we need to have some mapping.
Yeah, mapping. How will you create that mapping? We have the original documents. We have clustered numbers, automated way of assigning a group to each document. We need to map it. How will you map it? Manual intervention only. You take the documents belonging to one group, right? Maybe 10 documents, maybe 15 documents belonging to group 1, and read through them, and then find out which category it belongs to. Then assign 1 to, right, maybe paracetamol, right? take the documents belonging to two, second group, maybe 15 or 20 documents you take, that second group, read through them, find out the category it belongs to, right? Glycomet, like that. Got it? There is manual intervention. In AI projects, there is manual intervention. That's the point you need to remember. The third point is, right, there is no guarantee that always, in this one group, you will get a single category, data belonging to single category. Because if your natural language processing is not keeping the data's essence, the text's essence, while converting it to numbers, the clustering may not happen properly. When NLP, the technique you use to convert text into numbers, is appropriate, the clustering will happen appropriately. When I say clustering happens appropriately, all the documents belonging to group 1 belongs to one particular physical category, or the business point of view category. If not, right, they'll get mixed up. So there is no guarantee. Because of this, right, there is no guarantee that the clustering will exactly find out the groups. There will be error, right? In AI, there will be error. To correct that error, right, again manual intervention is needed. So once after building this model, and this clustering model, we may have to give a web interface or some other application, right? An application where we'll be showing the document here, and the group, the clustering assigned, and a human being will read through this document and maybe a drop down here and correct it and then save it. Right? So manual correction will happen. So it is, if we initially where we started, we took the documents and manually reading through all 10,000 documents and labeling it. Right? That is a tedious process. What we are trying to do is we are trying to add some automation to the process. How are we adding? First, we are passing this to an ML approach, right? Machine learning approach to cluster the data. We found some mappings, right? Once after finding the numbers, we found some mappings by manually reading through the documents, right? And then mapped it, right? Now we are feeding this mapped data to a web application. This is a web application or mobile application. Or mobile application is not possible because it's a big document, right? So you show the document, you show the group found by the algorithm, the k-means clustering algorithm. You ask a human being, right, a subject matter expert, whether this grouping is correct or not. Right? Maybe out of 10,000 documents, if our model, if our approach is correct, maybe 8,000 documents would have been correctly flagged. 2,000 we have to correct it, right? We will do that. The human beings should do that correction. This corrected data, right? Ultimately, the corrected data is the blue data. Now you have x1, x2, and so on xn, and the corrected y, right? Now you take this and build a model. Build maybe logistic regression or random forest or whatever, right? Whatever model you build, or deep learning model you build. Now you take the new document, pass it to this model, right? Then it will predict. Got it? Got the process? If you have this kind of a problem, clustering is going to be useful as an intermediate step. Once you got this intermediate step, you need to have some interface to correct the data. Once the data is corrected, you can use that data to build a model. Maybe you can use this clustered data also and build a model, and maybe you can predict also. But there is no guarantee. Clustering has got no guarantee. Unsupervised learning approach has got no guarantee that it will work perfect. It can be used as a support for human beings. Either it is PCA or the clustering. Okay, so maybe 8,000 documents it will correctly predict. Maybe 2,000 it will not predict correctly, but anyway, human being need to go through all 10,000 documents, right? All 10,000 documents anyway human being need to go through, but there will be a basis. Right? Sometimes you may read to 2 pages and you understand and leave it, flag it and leave it, or you find that the flag is correct and you leave it, right? Like that, right? It reduces the work here. Initial labeling activity can be reduced by using clustering algorithms. Okay. Got it? Any questions here?
So when a new record comes, it directly goes to the model and predicts. It won't go under the clustering process.
No. You know, if you are right, let me redraw this whole thing. Yeah, that's so you got documents. You passed it to clustering, right? Then you got for each document. Oh no, sorry. Give me one second. Write down the process. Extract text. Right? Then apply NLP and convert it into numbers. There is no way, right? Convert it into numbers. Then apply clustering process. Okay. Now you get y, some dummy y, right? Maybe I'll say x1, x2, and so on, xn, c underscore y, I'll say clustering based y. Okay, this is the process. Okay. And then you take this and pass it to an application, right, that corrects the data. CORRE correction. Okay. So this web application will have, it will show the first document, right? Original text it will show, right? First document it will show, and then the label assigned by c underscore y it will show here, and then there will be a submit button, right? So user will actually select it, submit. We are going to dump the data into database. Now when we are dumping the data, we'll take those numerical representation only. While dumping the data into database, we'll represent it with the numerical representation. This is the corrected by. Now you build a ML model. This is total architecture or design of the application. Okay, now you take that data and build ML model, or ML or DL model. Right? DL model. This is right. This is the process. Now you got a new document. Right? When you got a new document, what should we do? You got a new document. You need to apply this NLP process, whatever the process you applied, at all the pre-processing process, and convert that into numbers. Right? Pass these numbers to the model and make prediction. That's the process. Got it?
Yeah, but the new document which we want to predict might be of a different category.
Yeah, if that is of a different category, right? Again, you need to retrain the data, retrain the model. You need to feed the data into the data set, and it is that's the maintenance activity in AI, right? So when data patterns change or new kind of documents come in, you should actually retrain the model.
Yeah, it should actually should go into the web application kind of stuff again there, right?
Yeah,
and then it will correct.
As a maintainer or the business business analyst or maybe subject matter expert, you should be aware that new documents are coming in, and then you need to kind of there is some manual effort needed there.
Sir, sorry, go ahead.
Yeah.
I'm done with it. Go ahead, please.
Yeah, sir. Actually, one application of this clustering, what I'm just guessing, in the LinkedIn, we keep getting questions out of, let's say, 2-3 people I know in my contact list. LinkedIn will ask me for so and so technology, whom do you rate as the best person, like something like that. So I'm guessing it's a kind of the manual or maybe analogy to the web interface based corrections. Maybe they might have already built, and then they're trying to.
Yeah, that's a good point. They're actually collecting data. It is called as crowdsourcing,
Sure.
right? Instead of putting people to do this correction, they're asking
Yeah.
us to. They're
Yeah.
asking us to correct it. That is the key. Actually, the companies who doesn't care about AI will fail in near future because they will not have the data ready to build AI models. Right? Data currently the data present in the databases is useful to generate descriptive analytics and general purpose applications only. But the data is not intelligent, I would say. When you have labels, right? When you have labels in the data, appropriate labels in the data, that is intelligent data. You can build intelligent models on that. That's a very good point actually. That's what I say. Management should have clear picture of what AI does and how AI works. Rather, they will not make right decisions or they will not lead the team in right direction. Got it? You know,
Sure, sir.
if you see the companies, right? The process. Once IBM was very big, HP was even bigger, right? Now Google is big, Facebook is big, and the WhatsApp is big because technology trends are changing and management and the people are not that. When affluent, the company is affluent, right? They'll not care much. Right? The employees, they generally see whether we are getting our salary or not. Even we will become like that. As a startup, maybe some small companies may be striving, but at one point in time, right, they'll stop looking at the new things. That's where they stop. Many companies, the management doesn't have this thought process, how to collect data and make the data intelligent. That thought process is not there. And I would say the existing applications or existing products should actually do this in the database. Through application, if we can do that, right, the data collection becomes easy. Right? Model building is just a month or 2 months activity. Clean up the data, build a model. If you have to do all this, right, it will take maybe around 1 year. 1 year process to build a system like this. Right?
Sure, sir.
Yeah.
Thank you.
That's a good point, sir. That's a very good point. And now you see, right, when you are actually try to work on a project, how much time it takes, right? People may ask, like, how much time it took to build up. So I have taken this particular scenario because one of the projects we are going to handle will have this kind of an artist. I am thinking of doing it this way. Is this the right approach? I don't know. Right? If you talk about web application development or a integration, application, the product that does integration between two applications, there are many examples, many solutions. But now AI, this is pretty new, right? So we are designing new things, and maybe after some time, maybe 3-4 years, we'll know, pros and cons of different approaches, and then we'll get to know the clear and exact ways of doing it. Okay, so you understood where clustering is useful, right?
Yes.
And Google also does the same thing. Google News, right? Initially, they would have done some clustering, and they would have, initially they would have published it in Google News, and slowly they would have refined it, maybe using an application or something like this, or maybe they would have asked people. Even spam filter, email spam filter in Google does the same thing. Initially, we used to get spam mails into inbox. Now we are not getting because many people like us, right, would have flagged it. If you, I don't know whether you observed it or not. You would have. Right? If I open this mail, right, it asks you, is that a spam somewhere? Yeah, this one, right? If you report a spam, right, they'll take that data and put it into database and slowly refine their AI model. Now we are not getting all inbox. We'll get only inbox mails, no spam mails, because it improved slowly. It improved. They would have done it in around 2005 to 2010 time frame. Very early on they started using AI, so their email is very good, and Yahoo, Hotmail, everything is gone. because this Gmail is faster and intelligent. So that's the use of clustering. Now let us understand how k-means clustering works. There are different algorithms. I'm going to cover k-means clustering, dbScan, and optics. I think optics are some algorithm. Okay, I forgot the name of it. I'll cover these three. So how k-means clustering works? We know k nearest neighbors, right? This is also similar to that only. Okay, similar, not same, similar. So select k. Right? There also we were actually choosing the k, right? The k neighbors it should be looking into. Here we are choosing the k clusters we need to divide the data into. In our previous example, I said 10 clusters. I don't know whether it is going to be 10 clusters or 12 clusters or 15 or maybe 2 clusters only. I don't know. But randomly I said 10. Is that it? No. We can decide how many, or we will know how many is the best, how many groups the data can be done. We will be able to find it. Okay. But initially, to start with, we'll take some number. Here I took 3. So select k cluster centroids from data. These serve as initial cluster assignments for the observations. Right? From data, we'll choose 3 data points. This is the data, original data. And I don't know the colors initially. I just kept colors there, but everything is single color. And I chose 3 data points. Right? I randomly chose 3 data points. And then, right, I am actually trying to do this iteratively. Right? For each of the k clusters, right, from the first cluster centroid, compute the cluster centroid. Give me 1 second. I'm getting a call. Give me 1 second. Okay. Okay, sorry for that. so initially we'll choose a random number of clusters. Sorry, I will not choose a data point in the data. Sorry for that statement. Initially I'll choose, I am going to do 3 splits of this data, that is the k. I'm going to do 10 splits of the data, that is k is equal to 10. So here I said 3. And then what it will do is it will compute the centroid. How will it compute? It takes it assigns some number of data points to one cluster and then calculates mean of all those data points, right? I'll explain clearly what that means and in a moment, right? For each of the k clusters, compute the cluster centroid. The kth cluster, kth cluster centroid is the vector of p feature means for the observations in the kth cluster. So initially we say 3 clusters and randomly assign data points to clusters. Randomly assign data points to clusters. Suppose that there are 100 people in a classroom, or maybe 30 people in a classroom. Okay, we said there are 3 groups, and then randomly we picked people, right? Maybe 10 people randomly we picked and kept into first group, 10 people into second group, and 10 people into third group. Random it was random. Okay, now what we will do is we will take average of the those 10 people and try to compute one number. Okay, in this case, right, in data points it is going to be vector, and each data point has got multiple values, right? Each data point in a 2-dimensional space, each data point will have two x1 and x2, x1 and x2, x1 and x2. Like that, all data points will have two values. When you have to calculate centroid, right, you have to calculate mean of all x1s, mean of all x2s. Then you will get a mean x1, mean x2 as the centroid. Right? That's the point I was making here. For each of the k clusters, compute the cluster centroid. The kth cluster centroid is the vector of the p feature means for the observations in kth cluster. Right? So assign each observation to the cluster whose centroid is closest. Okay. Calculate the distance between data points and centroids using a measure such as Euclidean distance. Right? So we took 10 numbers, 10 data points, calculated mean, 10 data points, calculated mean, 10 data points, calculated mean. Now what we are doing? To that mean data point, what are all data points closest in the whole data we are calculating? Right? If we assigned some data point to a cluster, and if it is farther, we are going to change the cluster centroid for that. So it is like finding a leader for the group, right? If a leader is similar to the person, then we will keep the person in the same group. If the leader is not similar to the person, right, we will find whoever is similar to the person, right? Distance measure is that. We are going to measure the distance between each cluster centroid and all data points, and again take the second cluster centroid, calculate distance between all data points, third cluster centroid, calculate distance between all data points. Whichever are closest, we are going to assign those to that particular centroid. We will repeat this process until the centroid is not changing, right? So we assigned closest data points, right? Again we are going to calculate centroid to the new group of data points, right? Again calculate the distances between the centroids and the data. Again try to reassign the centroids. Okay? So basically the data points are changing. So let me try to show this. If you look at this edge, right, some of these data points colors will change. Okay, in the edge you observe at the edge, some of the data points will colors will change. When I slide through, see that this data point color changed, right? This data point color changed. Again, these two data points color changed. So initial cluster centroid was not correct. It actually tried to find out the distance between this data point and all the other, this data point and all the other, this data point and all the other. It found that, right, this data point belongs to this cluster, these two data points belongs to the red cluster, like that. See that? That red point came into the green one, the sea green one or blue ones went into red one. When I run that again, see that some more changed. So all these data points belong to this cluster. See, the cluster centroid is also changing, right? Cluster centroid is also moving, right? Observed it, right? Cluster centroid is also moving. That's how the k-means clustering algorithm will work. It actually takes a randomly assigns data points to clusters and then calculates mean of the data points, and then tries to look at the distances between the centroids and the data and finds out the closest data point, and then it actually moves like that. Does that iteratively until the movement stops. When movement stopped, that means it found the appropriate cluster centroid for the data points. Got it? Got it? Any questions on the theory?
Please.
It's a very simple algorithm. Okay, I said that initially when I was explaining it theoretically, I said that the clustering will assign some number to each group, right? This color is nothing but number 0, 1, 2 like that, right? The cluster number doesn't mean anything until and unless human beings who know business label it. Okay. So after doing this clustering, you need to randomly choose some documents, read through them, and understand the group and assign the group name. Manually map it and assign the group name. So that is theory, right? That is how k-means clustering works. So there is a there is a metric. There are two metrics basically. One is elbow curve, and second is Chilote score. Right? This is a little advanced one. I'll cover this Monday. It needs a little thought process. Today we'll see the elbow curve. Okay, what is elbow curve? So we did this clustering, right? We did the grouping. We don't know whether this grouping is correct or not, or whether the k is correct or not. Right? We chose 3 as the groups, right? A number of groups or number of clusters. But is the 3 correct? Or 4 correct, 5 correct, 6 correct? We don't know. So what we will do is we will actually iteratively take k is equal to 2, build k-means clustering, find out the error. K is equal to 3, find out the error. K is equal to 4, find out the error. K is equal to 5. So we are going to take the data, split it into 2 groups, find out the error. 3 groups, find out the error. 4 groups, find out the error. When you say error, right? If your group centroids and group data, right? If you say group centroids and group data, the distance between them is very less. That means that is the best cluster, right? If you took 3 groups and all the data points are actually close to first one, all the data points are close to second one, all the data points are close to third one. When you calculate distance between centroid and the data points, it is going to be minimal. The centroid and data points, it's going to be minimal. The centroid and the data belonging to that group are minimal, right? Then as a whole, right, the total error is going to be minimal. What is the error metric here? The distance between the centroid and the data points belonging to that group, and sum all of them, right? Sum for all the groups. First group you calculate the distance between the centroid and the data points. Second group you calculate distance between the centroid and the data points. Third group you calculate the centroid and the data points belonging to that group. Each individual group is having less error, a total is also going to be less. It is like Indian culture, right? In India, every home is good, the total country is good. That's what the philosophy is like that here. The clustering, right? The error metric is like that, right? So here, this is the formula, right? Within cluster variance, we call it as within cluster variance. What is variance? The difference, right? If you take 1 and 10, the data, the 1000 numbers between 1 and 10, and 1000 numbers between 1 and 1 million. In the 1 and 1 million data, the variance is going to be high. In 1 and 10 data, the variance is going to be low, right? Within cluster variance, how much varying data is present in a given cluster? So how can you calculate? The distance is the variance. So here we are taking the Euclidean distance, right? This is norm, right? Double bar means, double pipe symbol means it is Euclidean distance. So a data point and it's a centroid. right? Xji and Cj. Cj is the jth cluster centroid. Right? This is first cluster C1, C2, C3. Okay, and then Xij, right? C11, C12, C13, C14, like that I can actually say. These are all data points, green data points belonging to C1, cluster 1. So all the data points I took and the centroid I took for that cluster, calculate the equidistant distance. Okay, from I is equal to 1 to n number of data points belonging to this cluster. I took all of them. In the second cluster also, maybe k number of data points. I just took n here, right? But all the data, all the clusters will not have the same number of numbers. It is for notational purposes I have said. No, n may differ here. I is equal to 1 to n for C1, I is equal to 1 to k for C2, I is equal to 1 to maybe L for C, right? Maybe 3, like that. Okay. So I took individual within cluster sum of variance, within cluster variance, and then I am actually summing up all the clusters, k clusters, 1, 2, 3, each cluster. The goal of the objective of the algorithm is to reduce the cost here. Okay, so the k-means clustering algorithm will find this one, but we will choose the k which is giving you the minimal of all those, right? So in theory, if I have to say, diagrammatically, if I have to say, I did two clusters, calculated this, k is equal to 2, I calculated this, we'll keep it aside. K is equal to 3, I'll calculate this, keep it aside. K is equal to 4, calculate this, keep it aside. Like that I calculate till maybe 7, 8, and then see where exactly it is minimal, with for which k the within cluster sum of squares is minimal. I'm going to take that k is the best k, right? So I'll show, when you actually look into the code, right, you'll understand. It is called as, this is called as elbow curve. For 2 clusters, what's the error? Within cluster sum of squares. For 3 clusters, what's the error? For 5 clusters, what's the error? Like that. So this is called as elbow curve. Right? You look at this, it is like elbow, right? Your hand, no, elbow kind of thing. Wherever that error decrease is very steep, you take that as the best. So here, this is the steepest. Right, next steepest is this one, right? Maybe 5 clusters, but 3 is the most steepest error reduction. Okay, for between 3 and 5, the error reduction is not that much, but between 2 and 3, the error reduction is too high. Okay? So you take that 3 as the best clusters. This is called as elbow curve approach. There is a Shilhote's course approach. I'll explain that on Monday. Right. So let us look at the code a little bit and then start for questions.
Sir, 1 second, sir.
Yeah.
So, why do we need to take only that particular point? Because we said the lowest error means lowest distance. So,
So
in such,
that's a good question. If you take, if you have 100 data points in your data set, if you say 100, k is equal to 100, minimum error is going to be 0. Do you agree with that statement? If you
can
have
you please
100
repeat
data
that,
points, 100 data points in your data set, you take k is equal to 100, the error is going to be 0.
That is correct, sir.
Right? Each data point will become itself a cluster centroid and itself a data point. So we will not be taking that 100 as the cluster, right? Because it is minimal. So there should be a kind of place where we want to stop, where error is not reducing much. We are
Yes, sir.
stopping there. From
Yeah.
here, the error is not reducing much. That means this is the best way to group them. Even if you do this one, right, it may actually create groups which are unnecessary, right? Unnecessary in the sense, same data belonging to same cluster may fall into 2 or 3 groups, right? Error may reduce, but it may create that kind of a problem. Or other way is also there. Other problem is also there. There may be data points belonging to 2 groups and fell into one cluster also. If you take this, that's where human intervention is needed. That's where I was actually saying that there should be an application to correct the clustered data, right? As you said that LinkedIn is actually trying to do whatever, right? So, got it?
Yes, sir, it's clear.
Yeah. So let us jump in and try to look at the code. I have taken iris data. This is very simple data set, right? So for understanding purposes, it's going to be easy. So I have taken that data and I took only the input values, okay? No output values. And then see this here for k in range of 2 to 10, right? From 2 to 9, and I am building a k-means clustering. K-means is the class I would have imported. See this scikit-learn cluster and k-means, right? And then k-means k n clusters is equal to k. Init is equal to k-means plus, right? And random state is equal to 42. And then I fitted the model, right? And then I collected the the cluster centroids. When I say predict, right, it's going to give for each row which cluster it belongs to. When I say 2, right, it's going to be 0 and 1. First row may belong to 1, second row may belong to 0, third row may belong to 1, fourth row may belong to 1, like that. It's going to give, if you pass 100 records, right, 100 numbers will come. Each number belonging to a particular record, right? And then what I did is inertia underscore. I took k-means dot inertia underscore. This inertia underscore is the within cluster sum of squares. See this here? We were calculating this whole formula, right? This formula's outcome is going to be present in inertia underscore attribute in the k-means cluster. So I appended that to a, right, what you call it as the list. Right? Silhouette score I am appending, but we'll talk about this Monday. Right? I appended that. Right? Now I am doing a elbow curve. What is elbow curve? I took the cluster number on x-axis, the error on y-axis. See this here? Inertia underscore is the error. Okay. And the range, right? The range 2 to 10 is the clusters. Right? Second cluster, what is the error? Third cluster, what is the three clusters, what is the error? Four clusters, what is the error? Fifth cluster, what is the error? Sorry, 5 clusters. Like that I took, and then I did a elbow curve. So 3 is the best cluster I found, because beyond that, right, the error is not reducing anymore. Not reducing that much. Okay. Silhouette score also can be used to determine the best cluster. When we use the silhouette cluster, right, we got 6 also as a best cluster. So I'll show you tomorrow, right, on Monday, how exactly to use silhouette score and where to use it and all that. Now, k-means clustering basically focuses on forming circular clusters. Clusters. It actually tries to form circular clusters. That's the problem with k-means clustering. Even though the data has got other kinds of patterns, k-means clustering will try to form circular clusters. Basically, because of looking into the within cluster sum of squares. While forming the clusters, you are trying to find the best cluster by looking at within cluster sum of squares. But if you look into silhouette score, right, it may actually differ a little bit. Okay, so that I'll cover on Monday. So today's class is very small, right, because I am in hometown and the internet is not that fast. And when I'm trying to upload it, right, it is taking 1.5 hours to upload, maybe, whatever the file, 200 MB file is taking too much time. If I take too much class, right, I have to stay here to do that.